My name is Arda, and today I'll be going over a program called CyberBytes. In this program, we are encoding text to music and decoding music back to text while encrypting and decrypting text. So if you don't have the key, you're not able to read the code. Starting off, we're importing our libraries, and then we're setting up sample rates, durations of the notes, and low frequency, high frequency. Low frequency, we are assigning this to binary 0, and we're assigning high frequency to binary 1. We're using Fernet to generate a unique key every time, so whoever has the key is able to decrypt the data. And I'll be showing over the Fernet key that is generated as well. Here we are generating the UI. These functions are to convert text to binary and binary to text, and we're generating a tone for it to play. This function is encoding text to audio. Basically, by using frequency, and by using frequency, we are assigning frequencies to each binary number, which is ones and zeros. Basically, we're converting text to a bunch of ones and zeros, and we're converting these bunch of ones and zeros to a frequency, which is basically a note. And then at the end, we're reversing everything in order to get our text back. And we are encrypting the text before we encode it to the audio, so it is encrypted. And then this is a function to decrypt it. You have to have the key. And this is the UI, continuing with UI, and this is pretty much it. And this is the decoding function that decodes the audio file into the text file and decrypts as well. So let's run the program. This is our UI here. We can paste the prompt that was given to us, and if we click encode text to audio, this screen pops up. And after this screen pops up, we can save our file. I'm gonna name it file, and let's save this to desktop. And now that our file is saved, this is the encrypted text. So basically, this is the encrypted text that was encrypted by Fernet that our frequency will be playing. So we're gonna be converting this to binary zeros and ones, and then playing with frequency. So it won't make sense unless you have the key. In order to decode it, you can click decode audio to text, and then we can select our file. And decoded text is right here. Recognize and refer phishing, use strong passwords, turn on multi-factor authentication, and update software. So moving on to how this sounds, it sounds like this. As you can see, it's very rapid, very quick, bunch of ones and zeros, basically two notes going around. It doesn't sound very pleasing, but we also made improvements on the sound to implement piano keys to the sound, where it would sound like this. We had troubles encoding the piano notes because of the different frequencies, but if we have more time, we'll be able to do it. And in the future, we can also implement this to regular music pieces, like music pieces from Mozart and Bach, to classical pieces, and decrypt those or decode those different frequencies and from different notes. So that's for another day. Thank you for listening.